Hello, my name is Camilo Lagos, and I will be presenting our paper using percent plan completed for early success assessment in the last planner system, developed together with Professor Luis Fernando Alarcón. Operational management focuses solely on the transformation view. Planning is viewed as a single time event in which detailed schedules are formulated with extensive use of Slack, and control is result-oriented. Therefore, it presents several limitations. Deviations are only detected after the fact. The use of Slack can hide deviations, and aggregated indicators conceal variability. Traditional methods also fail to detect and prevent early signs of deviation. The last planner system has been proposed as an alternative. It has been used for over 27 years in multiple countries, and it focuses on the processes of work preparation and managing short-term commitments. Its impacts have been well documented and include improving performance and stabilizing workflow. Several metrics are used to trace work preparation, short-term compliance, and recurrent problems in project execution. Also, it connects short, mid, and long-term scopes of planning and control, and correlations are found between management practices, last planner metrics, and project key performance indicators, or KPI. Our aim of research is to determine how can quantitative last planner indicators, such as a percent plan complete, can be used to assess project performance. We will try to classify projects using outcome indicators, determine significant differences in quantitative last planner information, and identify which difference manifests at early stages. Our hypotheses are that the PPC is higher in successful projects and that successful projects have a lower number of reasons for non-compliances, both throughout project execution. Our scope is to use 25 Chilean projects that use the same IT support system for the last planner, and we've used standardized weekly information from the last planner system that was normalized into 10 progress intervals. And projects were classified into success and failure groups using clustering algorithms. Our methodology starts by reviewing literature with a focus on quantitative research and metrics, and the relationships between last planner indicators, project KPI, and project outcome. Then we collected information using the aforementioned IT support system, and we standardized and normalized the data so that projects could be compared. At stage 3, we use project clustering algorithms to classify projects as successful or failure. At stage 4, we perform aggregated data analysis to determine correlations between last planning metrics and performance, and also statistical differences between the two groups. Finally, we perform the same statistical analysis, but using the progress intervals to determine which of the differences manifested at early stages. Our initial data sample was composed of 48 high-rise building projects, but after filtering, we developed a study sample of 25 complete projects. The result indicators that we used were the schedule performance index measured at plan completion, and also a schedule deviation measured at project end. The aggregated last planning indicators used were the mean and standard deviation for the PPC, the total number of reasons for non-compliances, and the total number of reasons for non-compliances per week, both which were normalized per the number of project tasks so that they could be compared between projects. And evolution indicators were obtained for each 10% progress interval and consisted in the PPC average calculated for each interval, and also the accumulated PPC average throughout execution until that interval, and the same for the PPC standard deviation. The correlation analysis result show several correlations between last planner metrics and result metrics. For example, a higher PPC average is correlated to a higher schedule performance index and to a lower schedule deviation. Therefore, a higher PPC means better project results. In contrast, a lower PPC deviation also indicates higher performance. We also found correlations between the number of reasons for non-compliances and the result metrics. Here we present the main correlation found, which presents that a 10% increment in PPC reduces the schedule deviation by 8%, as shown in the figure. Then we performed clustering using a method based on k-means algorithm. We'd use the SPI and SD as parameters, and our method minimized the distance between each project and its cluster and maximized the distance between clusters. We used different numbers of clusters, but determined that the best results were obtained using 4 clusters. And we used the 2 clusters in the middle to detect the classification rules as it is shown in the following graph. As we see, successful projects, which were the 2 groups to the right, had a SPI higher than 94% and a schedule deviation lower than 8%. When we analyzed the aggregated last planner indicators between the 2 groups, we found that successful projects have a higher PPC value, average throughout project execution, a lower PPC standard deviation, and also have a lower number of reasons for non-compliances. Also, when we analyze and compare the reasons for non-compliances indicators to the PPC, we found that reasons for non-compliances have higher differences between groups than the PPC metrics. All of these differences were significant to a 95% confidence level. When we analyzed the interval indicator results, we found similar results. And as we can see here, the PPC average is greater in successful projects throughout the whole project execution. And these differences are more noticeable using accumulated PPC average for each interval. As we see here, successful projects have a stable increase in PPC throughout execution. Similar results are found when we analyze PPC deviation in each interval and accumulated until each interval. And as seen here, successful projects have lower standard deviation and it is more stable than in less than successful projects. Therefore, we can conclude first that correlations are found between last planner metrics and project performance, especially between the PPC and the schedule deviation. Projects with higher PPC had better results in our sample, and also these differences were noticeable since early stages of execution. And successful projects present a stable increase in PPC throughout execution. The limitations of our research is the use of a small sample composed of 25 projects using only 1 IT support system, and that our result classification was based only on schedule performance. The opportunities that we found is that LPS metrics can be used to assess expected performance at early stages, and data science tools like machine learning can be used to develop such rules. And also, we identified the need for more quantitative research with larger samples. Thank you very much for your time.